All right, class. So we're back for our last video here in regards to gas welding. And so far, we have covered what welding is, how to safely use a oxyacetylene torch, and how to weld with an oxyacetylene torch. What we're going to move on from for the moment is moving away from what we describe as welding to the second process that we introduced in the first video, which is mechanical bonding. And so, mechanical bonding, if you will remember, is using an alloy or some type of material to put or join two pieces of material together without melting the base materials. Really, like I told you all earlier, it acts like a glue, a very sticky substance that holds material together, and we call that a mechanical bond. Still creates a permanent joint, it just does not actually melt the material together, so it's not technically welding. The first of those processes is called brazing. And brazing is using a filler material that's melted down and distributed around by what we call capillary action, which means that it pulls itself. Very similar to raindrops on your windshield as they run down. That's capillary action. So it's forces that pull that around a joint. And that capillary action distributes that brazing material between the surface and the joints without the base material being melted. So it acts like you're just putting glue around that material, but it's a very sticky glue. This creates a mechanical bond between the two joined work pieces. Again, capillary action is a tendency of a liquid to rise or fall as a result of surface tension. Okay, so brazing is a very common practice that's used a lot of times in heating and air conditioning and some other types of joining processes as well. So the requirement of a brazing material is that it has to have a brass composition. Brass has a melting point of around 800 degrees Fahrenheit. So that means that you use braze when the workpiece has a melting point higher than 800 degrees Fahrenheit. Because the idea is that we want to melt the brass onto the material, but we don't want to melt the material. So anytime you want to join maybe two dissimilar metals with different melting points, as long as their melting points are higher than 800 degrees, braze or brass is a good option to do that. So you can see the brazing rod over here on the left. It has the brass in the center. It has this white material on the outside that's called a flux, which helps clean the joint and helps move the braze around. It will just kind of come off in a vapor when it gets heated up. And you can see a braze joint here on the right, and it's this brass-looking joint here where these metals join at. Other requirements of brazing material is it has to be fluid. It has to be able to be fluid. It has to be able to penetrate the interfaces of surfaces. If you look at a piece of metal, it may look slick on the outside, but metal is porous in some ways. So that brass braze goes down in those pores, and that's where the joints are. That's where it sticks to. Okay, it has to be chemically insensitive. That means it should not alter the chemical composition of the workpiece. And the flux, as I mentioned, helps the flowing of the brazing material into the joint, and it creates a shielding umbrella around the area to prevent impurities from entering the area. It also helps clean the surface of the material. Material should be clean. That's not talking about rust. It's just talking about helping clean some of the oxides and stuff off as it comes down. So a little more about torch brazing. It uses an oxyacetylene torch. So this is how you all will be introduced to the oxyacetylene this semester. You'll have a chance to do some torch brazing. We'll join two pieces of mild steel together using the torch. It does require a neutral flame. So what you do is you'll heat up the workpiece to allow it to get hot. The workpiece should get pretty hot before you try to apply the filling material or the braze onto the joint, because when you touch the braze to that hot material, it will melt and it will run downward towards the joint. And then if you happen to have a buildup of braze somewhere on your brazing operation, you can use heat to manipulate where you want it to go. So you can use the heat to move it around the joint to keep it from puddling up in a big blob. Other types of brazing include furnace, induction, resistance dipper, infrared. There are all different types of ways that you can do brazing. Again, this is very popular in the HVAC world. You can use it to join dissimilar metals or even similar metals as needed. Real quick, I'm going to show you all what this process looks like here underneath the document camera. So this is what torch brazing looks like here on the photo. You got the torch, you got the brazing rod going down to this joint. Also going to show you real quick here, like I said, on the dock cam. So here we have, this here is a piece of pipe that I brazed to a piece of sheet material. Again, it's the same composition. You can see how the braze kind of even infiltrated into that joint there. Brazing is not as strong as welding, so the joint's a little bit weaker, but to be quite honest with you, it's very sticky. So what you do is you take your torch here, you'll have it hot, you'll have a flame, you'll heat up this pipe till it's almost cherry red, and then you'll slowly stick this rod into the inner cone. It will touch this metal, and it will run down and create a concave structure right down in here. So concave means that it caves in, and it should go down around all the way around this material. Again, if you have a big blob, you can then just kind of heat it up and move it around as necessary. Okay. Last mechanical bond that we will talk about is soldering. So a lot of you all may have heard of soldering before when you're dealing with electronics. Same idea, except we're using bigger solder on bigger pieces of material. So soldering follows the same principles as brazing, but it has two major differences. Its composition is not brass, it's a combination of tin and lead. And its melting point is less than 800 degrees. So maybe you're starting to get a theme here that if your materials that you're trying to join together have a melting point of less than 800 degrees, you use solder. If it has a melting point of greater than 800 degrees, you would use braze if you don't want to do welding. Okay, solder's really used a lot on copper fittings and joints for plumbing, maybe HVAC and other things as well. So you can see over here on the left we have a roll of solder. On the right you can see copper pipes being soldered together. Some folks call it sweating copper as well. Okay, so the soldering process does require the material to be pretty clean. The joints should be tight fitting. And there are two different types of flux. So inside the solder themselves, there are flux. It can be either organic, which is rosin or water-based. This is what you use for electrical work. You should use an organic solder. Inorganic solder uses an acid-based flux. That's more than times used on metals that have oxide films, especially like aluminums. Okay. So the idea, just like with brazing, you should be able to apply the solder. You should apply enough heat to melt the solder, but not melt the base material. Common heat sources for soldering are propane and MAP gas, or electric iron for electronic welding. We don't use an oxyacetylene torch. It produces way too much heat for soldering. So propane torch generates less heat. It's easier to control, or MAP gas as well, which is a common gas that's used in industry. Solder does have a wide range of melting points, which makes it a useful tool in various applications. So where will you all use solder at? The galvanized pans that you all cut in Lab 2 on the big squaring shear, you marked and you notched in Lab 3, you bent in Lab 6, the little small galvanized pans. We want to make joints in the center or on the corners where the folds come together. But the problem is it's galvanized. And galvanized has a melting point of around 600-ish degrees, 400 to 600 degrees. And so we can't weld it. That'll melt off the galvanization, and which will ruin the idea of keeping the pan from corroding and rusting. We can't braze it. It'll melt it. So the only way that we can join these corners is through soldering. So you will have a chance to use a propane torch and a roll of solder to solder those four joints together. And then you'll have to test to see if the pan is watertight. So soldering is a really useful skill to have, both with electrical and with metalworking. So you'll get a chance to explore that process in the lab coming up in Lab 7. All right, so that's all I have for you all on gas welding processes. Up to now, we've talked about oxyacetylene welding, brazing, and soldering. In the next set of videos, we'll begin an introduction into electric arc welding, and then we'll talk about some of the more common welding processes that you've probably heard of before. Until then, I'll catch y'all in the next video. Take care.